Hi guys, I just wanted to finish page 5 from the homework, so not from the homework, from the packet. If you can pause the video and take out your packet. Just wanted to review, and I wanted to write the definition of horizontal asymptote. So, based on the cases and based on the graph, we knew what the horizontal asymptotes were. Please make sure on a quiz or test you write down y equals. If not, you will get points taken off. No horizontal asymptote, and the asymptote here was y equals 0. Let's hold off on these, right? I'm hoping I convinced you that the cases don't work, and then it's not really easy to graph this without the help of a calculator, so if you could just let these two be for now, that would be great. Then I asked you to go use your calculator and find the limit as x approaches infinity, and this function approached 2/5, this function approached 0, this function approached infinity, which means does not exist, and this function, as I approach infinity, went to infinity and then does not exist. So I'm trying to teach you the definition of horizontal asymptote. And again, this is what we were saying in class, that these two values are the same, and these two values are the same. The fact that there was no horizontal asymptote coincides with the fact that this does not have a limit. And so here's what happens with this. Obviously, 3 times e to the x does have a horizontal asymptote. If I don't get the limit as x approaches infinity to give me 0, then that means the limit as x approaches negative infinity of 3 times e to the x will give you 0. So here's the definition of a horizontal asymptote. Just listen to me and then I'll write it and you can write it with me. The limit as x approaches infinity of a function, if that limit equals a value, that value is the horizontal asymptote. Same thing here. The limit as x approaches infinity of a function, look at it, equals 0, and the horizontal asymptote was 0. If the limit as x approaches infinity does not exist, or goes to infinity, which is the same, then there is no horizontal asymptote. However, try out the limit as x approaches negative infinity. If that gives you a number, then that's a horizontal asymptote. But you can do this on your calculator. As you approach negative infinity for this function, I believe the answer is infinity. I'm not sure if it's negative infinity or infinity, but I know that it doesn't exist. It doesn't produce a number. So here's the definition of a horizontal asymptote. You take the limit of the function as x approaches infinity. If it approaches a number, that number is a horizontal asymptote. Turns out that you can get neither of them, meaning as you approach infinity or negative infinity, you can get neither of them to give you a limit, so there's no horizontal asymptote at all. If x approaches infinity does not exist, and x approaches negative infinity gives you a number, then the 0 is the horizontal asymptote. Last thing I want to say, sometimes you'll have, as x approaches infinity, give you one number, and as x approaches negative infinity, give you another number. So, turns out you can get 2 different horizontal asymptotes. You can have just one, you can have none at all. Again, you can have one, and it's because x approaches negative infinity produce that. When you do the homework, you'll realize that as x approaches infinity, you get one value, and not infinity to any, but you actually get a number. And as x approaches negative infinity, you get another value, so you have 2 horizontal asymptotes. All right, here's the definition. The line y equals b is the horizontal asymptote of a function if and only if the limit as x approaches infinity of the function is b, or the limit as x approaches negative infinity of f of x equals b. This happened right here. As x approaches infinity, I didn't get a number. But as x approaches negative infinity, I did get 0. This is how you find horizontal asymptote in calculus. Even if there's a problem where you can apply the cases, I still need you to evaluate these 2 limits. Okay, thank you for watching, and now you can start the textbook problems.